Fly me to the moon, let me play among the stars.
Fly me to the moon and let me play among the stars. Let me see what spring is like on Jupiter and Mars. In other words, hold my hand. In other words.
Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Spot and Doug.
Mentos and Diet Coke Rocket. And here it comes. It landed on top of the roof.
While the average person might not care about it, space exploration is arguably one of the most impressive things we've done in the 20th and 21st century. Most people wouldn't be able to live without GPS or satellite communication networks that we have because of it. There's a good reason why most people consider stuff like Apollo 11 on the same level as the eradication of smallpox. So far, we've been sending probes and have been exploring throughout the solar system, from the inner planets like Mercury, Venus, and Mars, from the outer gas giants and their large, magnificent ring structures and moons. The future of spaceflight will probably start traversing the far reaches of our cosmos. We'll first start with our stellar neighbors like Alpha Centauri. But this raises a very interesting question. How will we get here? In fact, how did we get here? Well, to answer that question, we have to go back. And I mean back, all the way back. Our journey begins approximately 315,000 years ago, with early humans just simply looking at the stars above them. At this point, the only way we knew about the cosmos around us was by simply looking at it and observing. At the late Paleolithic period alone, a mammoth tusk that's over 32,000 years old was found with the star chart Orion engraved upon its surface. In ancient Sumeria, Sumerians were able to use math to predict future astronomical events. In the Gupta Empire, or what is now known as ancient India, a man by the name of Aryabhata was able to discover the fact that the Earth not only rotates on its own axis, but the moon is able to light up in the night sky because it reflects off sunlight. Eventually, a Polish man by the name of Copernicus would come into the scene. Copernicus started the idea of heliocentrism in Europe, which would kickstart the Copernican Revolution. Later on, a famous Danish nobleman by the name of Tycho Brahe would start to grow his reputation. Brahe even got his own observatory named Uraniborg on a famous Danish island. Brahe would make multiple observations of the sun and the moon at that specific place. Brahe's biggest contribution was the massive amounts of data he collected for astronomy and the planets themselves. When Brahe died in 1601, his assistant, Johannes Kepler, would eventually take over. Kepler would spend years studying over Brahe's findings and observations. He'd eventually study the orbit of Mars and realize that its orbit is elliptical and not circular. This would be one of his 3 laws of planetary motion that are applicable today in almost every orbit you see. The Italian astronomer Galileo Galilei would eventually hear of the invention of the telescope by a Dutch inventor. Galileo would build his own telescope where he would observe the craters of the moon's surface, revealing the moon as another world worth exploring. Galileo would also discover the moons of Jupiter with his small telescope. Galileo would eventually observe the orbit of Venus and discover it had phases similar to the moon. This could only be possible if the world had the heliocentric model, and that geocentrism, the idea that everything revolves around the Earth, was simply wrong. Galileo's reward for benefiting mankind was getting put on infinite house arrest. Decades later, famous English physicist Sir Isaac Newton would write Principia Mathematica. This would describe the laws of motion and universal gravitation, and how he explained how they related to the entirety of the universe around us. Centuries later, a Russian school teacher by the name of Konstantin would write about space travel ideas, from Earth's escape velocity to airlocks to even biological life supports. In the United States, Robert Goddard would get to work on rocket science. He would make the first ever liquid-fueled rocket and launch it on March 16, 1926. Goddard made many steps from the first gyroscopic rocket and his early flight in 1929, which carried the first ever scientific payload, including a barometer and a camera. Now that we've covered early space pioneers, when did humanity reach space? During the 1940s, when Nazi Germany expanded and invaded throughout the European continent, the Allies proceeded to start bombing campaigns all over Germany. This would spearhead the V2 program, or Vengeance Weapon program, primarily headed by Nazi scientist Werner von Braun, and who was also held by his mentor, Hermann Ober. The V2s were mostly composed of slave labor, with deaths of up to 10,000 because of making these rockets alone. The first V2 was launched on September 7th. This was a double launch, which failed initially. However, more launches improved the quality of it, even though it really didn't have that much of accuracy. The V2s bring death and destruction all over Europe. The death toll in Britain alone was 2,724 people because of these rockets. Now you may start to wonder why this even matters at all, because it all seems pretty irrelevant. To answer that question, MW-180-14 became the first man-made object to reach space on June 20th. This was a test to see how the rocket would perform in the vacuum conditions of outer space. This test started at the Peenemünde Army Research Center, and it was a part of a series of vertical launches of the V2 rocket to reach space. The research was used to benefit the Nazi war machine. After the war, Germany was completely partitioned by the Allied powers, and the three remaining superpowers in the world decided to take it upon themselves to hire Nazi scientists to work for them. Werner von Braun and other Nazi scientists eventually surrendered to the United States Army for Operation Paperclip. They thought his skills were useful enough, and they eventually decided to send him to Fort Bliss, Texas. Eventually, they would reach the white sands of New Mexico. At this very launch site, multiple V2s were tested and deployed by the United States. At the end of Operation Paperclip, the United States had successfully snagged over 100 V2 rockets from Nazi Germany. They had snagged over hundreds of scientists from the construction of these rockets and had successfully taken most of them from the Soviets. April 16, 1946, the first V2 rocket from America launched. Early V2 flights like this one usually had scientific experiments equipped on them. Most of these experiments were supervised by Dr. James Van Allen. Later, a V2 rocket carrying a 35mm camera would take the first ever picture of Earth from above the Kármán line.
Air Force pictures show the rocket in flight, and the flying camera automatically takes over. The huge projectile drops the Earth behind at the tremendous speed of 4,000 feet per second. The rotation of the rocket causes the planet to spin before the lens, and the camera photographs the Earth 65 miles straight down. The horizon, 720 miles away, and the curvature of the Earth are astonishingly apparent in this still picture from the film. An observer in the rocket could have seen San Diego, Salt Lake City, Kansas City, and San Antonio.
Over a year later, on February 20th, 1947, fruit flies would become the first ever living organisms to reach space. Riding on another V2 missile rocket, these animals would be sent up to space to test the brutal effects of cosmic radiation on living organisms. Over a year later, again, the US would launch a rhesus macaque monkey named Albert on June 11th, 1948. However, on his way to space, Albert would slowly suffocate and die before he could even attempt to reach space, only topping out about 63 kilometers up, or 39 miles. Albert II would also launch on a V2 rocket a few days later on June 14th, 1948. However, his parachute system failed and he just crashed into the ground. Albert III just exploded on his rocket, and Albert IV also had another faulty parachute system. Then Albert V also had another faulty parachute system. It wasn't until Albert VI that the US finally could recover rhesus macaque monkeys alive in space. 9 years later, at the International Geophysical Year, President Dwight D. Eisenhower would announce the launch of US satellites. 4 days later, the Soviet Union under Leonid Sedov would do the same. But how do you get a satellite? To answer that question, we have to go back to our boy Isaac Newton. Let's say you, hypothetically, were on a mountaintop, and let's say you also had a cannon near you, and let's say you wanted to light that cannon, what would happen is that the cannon would explode immediately and then would launch a cannonball miles away from you. The cannonball would follow an arc trajectory due to its gravity and acceleration. However, let's just say that you gave this cannonball even more acceleration. The ball would be sent flying out into space in another direction. Due to its velocity, it would curve away from the Earth's surface, never hitting it. However, gravity would still affect it, so it's just continuously circling Earth. And this is how artificial satellites are made. USA would have 3 proposals to get a satellite into Earth orbit. The first one was the United States Air Force, which would use an SM-65 Atlas V missile. This was initially rejected because the Air Force was unable to produce an Atlas rocket in time for it to work. The second proposal was the United States Navy, which would use a Viking sounding rocket and turn it into a modified multi-stage vehicle capable of delivering payloads to orbit. Before this, there was Project Orbiter, a joint Army and Navy convention which would have a modified Redstone rocket. However, this was completely scrapped and the idea never really took off. The Army had its own plan, which would have von Braun work on a Juno 1 missile from the previously mentioned Redstone rocket. However, this was also rejected. Eventually, Dwight D. Eisenhower would choose the Navy proposal, or how it was renamed as Project Vanguard, for a few reasons. The first reason was that the Navy project was a more scientific endeavor due to these sounding rockets. The second was that it could place a satellite around Earth in a short amount of time. And the third was that it can conduct a scientific experiment.
Meanwhile,
in the Soviet Union, Sergei Korolev was busy designing and improving on the R-1 rocket, which were just modified V-2 rockets stolen from the Germans like the USA did. The R-1s were turned into R-2s, which had increased range and better accuracy. Eventually, the R-2s were turned into the R-3 rockets. These rockets were horrible as they had bad range and bad engines, and the program was completely cancelled. This would turn the R-3s into the R-5 rockets, which were much larger and much superior. Eventually, Sergei turned them into the R-7 intercontinental ballistic missile. Korolev originally wanted something called Object D, a scientific payload to be launched on the R-7. However, Object D was scrapped due to weight concerns and became Sputnik 3. Sputnik, on the other hand, or Traveler, would eventually become the first ever satellite to ever reach Earth orbit. Sputnik was no bigger or heavier than your average human being, only weighing 187 pounds. It was a small aluminum sphere with a nitrogenous atmosphere inside of it. A small radio and antenna were able to bounce off waves in the ionosphere.
On October the 4th, 1957, while the Americans were still finalizing their plans, Sputnik was launched.
Then its casing opened. The springs snapped, and the nose cone was pushed out of the way. A ball with 4 antennae emerged to go it alone in the darkness of space. And a radio began to...
Sputnik orbiting over Earth, the American public was put into a complete crisis about it, that the Soviet Union could potentially outcompete them, leading to the space race.